Hi students, welcome to Mahila Samaja online digital classroom. We are all watching continuous class of number system. In this, we are going to study about clearly rational numbers and irrational numbers. In this class, we are learning these points in this class, that is meaning of rational numbers with example, rational numbers between the given two rational numbers, conversion of rational numbers, a representation of rational numbers on the number line, meaning of irrational numbers, and a representation of irrational numbers on the number line. Next, study one by one. First one, rational numbers. The numbers which are converted from fraction form to decimal form or decimal form to fraction form. In both the way it is possible. And one more definition, the numbers are periodically repeated or terminated in its decimal form. For example, 1 is divided by 2, its decimal form is 0.5. Next example, 10 divided by 3, its decimal form is 3.3333, so on. So next point, many more rational numbers between any two given rational numbers. Its meaning is, if they can give you two rational numbers, you want to write many rational numbers in between that two rational numbers. This one you can represent in two forms, namely decimal form and fraction form. I am going to explain these two by taking an example. Example, write rational numbers between 3 and 4. First, you should have to represent in decimal form. Observe this point, these numbers are the students, 3.111, so on, so on, 3.2222, so on, so on, 3.333, so on, so on, etc., etc. Up to you can write 3.999. What you observe of these numbers, something it is numbers are repeated, no, here same numbers. Yeah, absolutely. These numbers are very easy and easily you can identify, as well as easily you can keep in the mind. And examination point of view, you can easily remember these points. That's what I am taken these numbers, identical numbers. Other than this, many more rational numbers are there in between the 3 and 4. Next, fraction form. Here also I am going to take same example, write rational numbers between 3 and 4. For this, just fraction, I am going to convert this whole number 3 into the fraction form. It means 3 can be rewrite as 9 by 3. If you divide 9 by 3, so it can retain the 3. Same similar, 4 can be rewrite as 12 by 3. 9 by 3 and 12 by 3 are the two rational numbers. In between that, 10 by 3 and 11 by 3 are the two rational numbers. It should be lying in between these two numbers. Sir, what you are saying? Only two numbers it should be lying. No, enormous number of rational numbers are lying in between these two. But these two are very simple one, so easily you can write. If you need more rational numbers, then we want to find out its equivalent fractions. Okay, students, how do you find out the equivalent fractions? So that is very simple and very easy. Don't worry, students. Let us observe here. 9 by 3 and 12 by 3, it's equivalent fractions. We are going to get like this. 9 by 3 is divided and multiplied by 3 to get its equivalent fraction. And here also 12 by 3 you can multiply and divide by 3, so you can get 36 by 9 is equivalent fraction for 12 by 3. Its meaning is both numerator and denominator of the fraction is multiplied by same number. ಯಾವುದಾದ್ರೂ ನಂಬರ್ ತಗೊಳ್ಳಿ ನೀವು, ಅದಕ್ಕೆ ಸೇಮ್ ನಂಬರ್ ತಗೊಂಡು ನ್ಯೂಮರೇಟರ್ ಡಿನಾಮಿನೇಟರ್ನ ಮಲ್ಟಿಪ್ಲೈ ಮಾಡಿದ್ರೆ we will get the equivalent fraction. So now 27 by 9 and 36 by 9, these numbers, now you can write many rational numbers in between these two fractions, that is 28 by 9, 29 by 9, 30 by 9, 31 by 9, 32 by 9, 33 by 9, 34 by 9, 35 by 9. Like this, if they can give you any two rational numbers, so you can convert into fraction, then you can find out the many rational numbers between the rational numbers, given two rational numbers. Next important topic is conversion of rational numbers. So already I told fractions to decimal and decimal to fraction. So in this one by one we can study with the example. First one is fractions to decimal. So students, this is very easy method. Already you are all learned in the lower classes, that is by division method. Let us take one example here. 10 divided by 3. 10 is divided by 3. We are going to get its quotient is 3.333. If you continue like this, so its remainder cannot become a 0. So next, second example, 7 divided by 8. If you divide 7 by 8, its quotient is 0.875. But at one stage, its remainder becomes 0. So from this, we are going to get two important results. So that is, remainder never become a 0. Then its decimal expansion of the rational number is periodically repeated. Second one, remainder becomes 0, then its decimal expansion is terminated in its rational numbers. Next, decimal form to fraction form. This is also very important for the mathematical calculations. So let us observe these students with the example. I am going to take here 3.333, so on so on. This 3.333 you can rewrite as, it means short form. 3.33 is equal to 3.3 bar. It means period of the decimal number. I am represent below the bar. Next, take x is equal to 3.333 as a equation 1. This equation you can multiply 10 on both the sides. If one decimal number is there below a bar, you can multiply it by 100. Sorry, 10. So both the sides, then 10 into x is equal to 10x, that is equal to 33.333. Then 10x is equal to this 33.33 you can rewrite as 30 plus 3.333, so on so on. Next, bring down this x to this side, then it should become 10x minus x is equal to 30. That is simplification. 9x is equal to 30. Next step, the x is equal to 30 by 9. 30 by 9 is a fraction form of 3.333. If you divide 30 by 9, it means simplification. Then x is equal to 10 by 3 also you can write. So which is a decimal form of 10 by 3, students? So that is 3.33. So what is a fraction form for 3.33? 10 by 3. So I am going to explain one more example here. That is 1.2727, so on so on. Here, period of the decimal number is, I am going to change here, that is 2 times. It means this 1.2727 can be rewrite as 1.27 bar. That is the main difference between first example and this example. So here under the bar, 2 digits are there. Take x is equal to 1.2727 as a equation 1. This equation you can multiply it by 100. So 2 digits are there under the bar. So hence it should be multiplied by 100. Now equation 1 become 100 into x is 100x is equal to 1.2727 into 100. So 127.2727. Next step, 10x is equal to 126 plus 1.2727. So let us substitute. So x is equal to 1.2727, that is in this step. So then 100x minus x is equal to 126. Then 99x is equal to 126. Then x is equal to 126 divided by 99. If you simplify that, its fraction is x is equal to 14 divided by 11. What is the decimal form of 14 by 11, students? That is 1.2727. So next is a representation of rational numbers on the number line. So it is very simple one. Diagrams are very attractive as well as very interesting. That's what. So graphical representation is always very interest for the students as well as everyone. Diagram means it should be attracting. That's what. Each and everything in the universe we are going to represent in the form of diagrams. This is the representation of rational numbers on the number line. Already you are well familiar how to represent the natural numbers, whole numbers, integers, and also your practice in the 8th standard about the graph. There also we are represent the numbers on a number line. Likewise, here also we can represent a rational numbers on the number line. For example, 2.665 can represent on a number line. For this, stepwise we are going to do it. 2.665 is lying in between 2 and 3. Okay, in next step, 2.665 is lying in between 2.60 and 2.70. Do you clear, students? Okay, next 2.665 is lying in between 2.660 and 2.670. So let us observe here number lines. I am visualizing these numbers. So here your 2.665 is lying in between first step 2 and 3. So in second step, your 2.665 is lying in between 2.6 and 2.7. In next step here, your 2.665 is lying in between 2.60 and 2.70. In next step, 2.665 is lying in between 2.660 and 2.670. Next, irrational numbers. The numbers which are having irrational root or the numbers whose decimal expansion is non-terminating or non-recurring is called irrational numbers. For this, we are already taken examples: pi, comma root 2, comma root 3, comma root 5, comma 1.414, comma 3.141, so on, so on. So these numbers also we can represent on the number line. It is also very simple as well as a very easy. So for this, I am going to take one example, represent or locate root 3 on the number line. Here, in first step, draw a number line between -1 and 1. Just observe the graph. This is, it means number line -1 and 1. Next, second step, draw a perpendicular at B, that is BC is perpendicular to XAB line segment. Okay, so next step number 3, join AC. If you join AC, then it should become ABC is a right angle triangle. Why it is, students? Because at BC is perpendicular to XAB. Perpendicular means it is always representing your 90 degree. That's why it should become a right angled triangle. Now here AB and BC are 1 unit measurements. Okay, it means measurement of the sides AB and BC are 1 unit. So observe the diagram. Okay, so now apply the Pythagoras statement for right angle triangle ABC. According to Pythagoras, square on the hypotenuse is equal to sum of the squares of the other two sides in a right angle triangle. Here AC is your hypotenuse. So AC square is equal to AB square plus BC square. Then substitute the values. 1 square plus 1 square, that is equal to 1 square means 1. So 1 square means 1. 1 plus 1 is equal to 2. Then your AC is equal to root 2. Now you can take AC as a radius and draw an arc which is touching your XY line segment at E. Now AC and AE are the radii of the same circle. What it is indicating? Radii of the same circle is always equal. Now AC and AE are root 2. Hence AC, AE is on number line XY So your AE is equal to root 2 on the number line. In next step, root 3 on a number line. So in the previous step, we are drawing a 90 degree at B. Now you can draw a 90 degree at C. How it is? It is very simple. Draw a perpendicular to the AC and point E. Then you can join AE. Now it should become AEC is your right angle triangle. Why it is? Because angle C is equal to 90 degree. Then once again you can apply the Pythagoras statement here. AE is your hypotenuse. AE square is equal to AC square plus CE square. Here AC is already we will find out in the previous step root 2. Its value is root 2 and CE is 1 unit. So now root 2 whole square plus 1 square. Root 2 whole square means its value is 2 because square and square would get cancelled. Okay, plus 1 square means 1. Now AE is equal to root 2. Now again here AE, you can take it as a radius, A as a center, draw an arc which can touching your XY line segment at D. Now AE and AD are the radii of the same circle. We already know that radius of the same circle is always equal. Then AE is equal to root 2, root 3 and AD on a number line. Okay students, this much in this class we have studied. Further we are going to study in next class. For based on this, so you can take the home assignment. For this, question number 1, find 5 rational numbers between 1 and 2. Question number 2, find 3 rational numbers between 3 by 5 and 4 by 5. Question number 3, find decimal form of 20 divided by 6 and 1 divided by 7. Question number 4, find P by Q form for question number A 0.333 so on. Question number B 0.001 under the bar. Under the bar is 3 digits. So next question number 5, represent 3.765, a rational number on the number line. Next question number 6, represent root 2 and root 5 on number line. Thank you students.